Hi everyone. I hope you all are well. I would like us to look at some example on chapter 4. So the first example I want us to look at, and please go through this video before doing any assignment in chapter 4. So the first thing I'd like you to understand is how to read the property table. So there is something you have to understand. There are so many property tables you will find there. And most of the time you will still see the same number, table A4, table A5, table A6. There are so many properties because there are so many properties that are out there. We have temperature, we have pressure, we have specific volume, we have internal energy, we have enthalpy, we have entropy. Those are properties. So there are so many property tables you are going to see out there. But what is more important in this course is you have to be able to know the right property table. And how do you know the right property table? In the question, you have to be able to know the kind of process, and therefore the kind of property comes from the kind of process that we are talking about. For example, we study property in different states: vaporization, saturation, and saturated water, saturated vapor, saturated liquid. Those are different phases in pure substances that we began looking at in class. So right now we have a rigid tank that contains 50 kg of saturated liquid at 90 degrees Celsius. We have to determine the pressure in the tank and the volume of the tank. So the first thing you want to ask yourself is, what is this question all about? I will start by highlighting the most important area. We have a rigid tank that has a mass. So we have a mass of 50 kg. But what is more important here is that we are dealing with saturated liquid. So be careful. So from this statement of saturated liquid, I can tell you that my table of property is saturated water, because I'm clearly seeing saturated liquid water. So it has defined my table of property. So that's how you are able to tell the kind of property table. So I know the property which I'm looking at, a property on saturated liquid water. So you look at the property table for saturated liquid water. We have to determine the pressure in the tank and the volume of the tank. Firstly, I have the temperature given. So I can tell you that the pressure can be gotten at the saturated liquid water temperature. So I say saturated temperature of 90 degrees Celsius, and I know this is the temperature which I have on my property table. This corresponds with temperature, this corresponds to pressure. So I am told it is 90 degrees Celsius, and I see here the property is 90 degrees Celsius. So I can see that here is the pressure, so I have the temperature, so I corresponds by mapping the pressure, which becomes 70,183 kilopascal. So that is how I get the pressure. So the pressure is 70,183 kilopascal. So you get the pressure at the temperature given on the problem on your property table. How do I determine the volume of the tank? I go from first principle. What is volume? I know that from volume, I could be able to get the parameters or the variable. I know that volume is equals to what? Mass times specific volume. So this is volume, and this is mass, and this is the specific volume. What specific volume? Specific volume of liquid. You must be specific. Not any kind of specific volume, because we have specific volume of vapor and we have specific volume of saturated liquid. Both are given on your property table. And therefore you have to be specific to say that you are looking at the specific volume of liquid, because we have but liquid water in this question. And what is that value? The value is, you see, is this, because this is the section for saturated liquid, and this is the specific volume of saturated liquid at the defined pressure and temperature that was given. So I have this value given as what? Given as 0,001036, and that becomes my specific volume of saturated liquid, still from the property table. And now I can solve for my volume. So my volume become what? The mass of saturated liquid, which is 50 kg, times this value which I have gotten for specific volume of saturated liquid. And when you do your mathematics, this is going to give you are going to have 0,0518 cube meter cube. So that becomes the solution. That's how we determine the volume and the pressure, by making use of the property table. So we are moving to the next question. So for the next question, we are told that a piston cylinder contains saturated water vapor at a given pressure, and we need to determine the temperature and the mass of vapor inside the cylinder. Like I said, you have to ask yourself a fundamental question. Which property table am I going to use? And how do I make such determination? To do that, I look at the question and I see that a piston cylinder device contains 2 foot cube of saturated water. So this is the working fluid. The working fluid is saturated water vapor, and therefore I look at my property table for saturated water, and that is my property table. So therefore I'm going to use table A5E in solving this problem, because the question says saturated water vapor, and if you look among all the property table, this is where I'm going to see saturated water. So this is the right property table. I'll be checking on your exercises to see where you are, to see your property table, and I'll always tell if you are using the wrong property table. So be careful not to use the wrong property table. So what am I looking at? I need to get the temperature for saturated water vapor. If I look at my pressure, which is what I showed you in the previous example, this is the pressure. I think you don't see what is there, so let me clean this so you can see. So this is what I have. This is the saturated water vapor. That is the pressure. So technically, I want to be able to determine the temperature at saturation, because the question says I should determine the temperature of saturated water vapor. So I just write a short abbreviation to talk about that, which is the saturated temperature of water at 50. And if I look at my property table, it is 280, it's 280, so I didn't see clearly. I guess my eyes didn't see it right. So it is 2 at 50, it is 280,99, and I see the temperature is measured in Fahrenheit. So at a pressure of 50 on the property table, I got the temperature of saturated water vapor. So it's quite easy to get the pressure or the temperature from a property table if you are given one variable. Now, I need to solve for the mass of vapor inside the cylinder. Remember, you have to be careful. We are talking about vapor. So look at your property table. How do I solve for the mass? What is mass? We know for sure that mass can be given as what? Mass can be given as volume over specific volume. So mass is volume divided by the specific volume. It's always good to remember this formula from first principle, because you need these formulas to be able to know which property to get. But what mass are we talking about? Mass of vapor. So we're talking about mass of vapor, not just mass of liquid, but mass of vapor. So it's important to know that. So when I look at my property table at 50, I need to get the mass of that particular fluid, which the question says mass of vapor. So what is the mass of vapor? I have it, I have the volume, and I need to get the specific volume. So when I look at vapor at this pressure, I need to get a specific volume. We have this section that talks about vapor, saturated vapor, and that is the specific volume. You see Vg, so I come to 50, and when I come here, this is what I have. So the specific volume for which is with Vg, the specific volume for vapor at saturation point is 8,5175. And what is the unit? It's going to be a bit dirty, you might not see clear, but let me just write the unit in foot cube per pounds. And therefore, now I can solve for the mass of vapor, which is the mass of vapor, which becomes the volume, and we have to, I don't think you can see that clearly, it's 2 foot cube. Let me clean that. Over and therefore we have the mass of vapor giving us what? 0,235 pounds. So that's the mass given. Now, you may spend time to go through these two exercises and look at some of the examples I'll give you. And then next week in class, we have to look at questions that talks about on Tuesday, we have to look at quality and specific volume change in a system and solve problems in that section. So have a nice weekend, and please watch this video before you try some of these problems that I'll give for the assignment. Thank you. Bye-bye.